So welcome back to the second video for lesson 3.2. We are looking at the standard deviation for weighted or grouped data. And you're going to put the data into Desmos, and you'll have to put it into a table where you have your values in X1 and then your frequencies in Y1. And you can do the mean right in there, and then you can also do the standard deviation. So if we go to Canvas and click on my Desmos link, anytime you're using my Desmos links, just save them in your own Desmos account, because then you've got them to use whenever you need them. And so just make sure you're changing the X1, Y1 to whatever is open, whatever table reference is in your data. So if we go to example 4 and 5 here, we can go back to the data that we looked at as far as the hours that teenagers spend on video games. And you can see in my Desmos file, I'm going to share my screen here, that I've got X3 and Y3 is where my data is. And that's what I'm referencing in this formula. And this formula is very large and complicated. And so it's important that you just copy mine. And take your data value or your midpoint and subtract the mean, which I'm calculating here, and then multiply it by Y3, which is the frequency. And then you're going to add up those differences squared and divide by n minus 1. Remember, when you have sample data, you need to divide by n minus 1. Or if you have grouped data, you always have to divide by n minus 1. And then that will be your variance. And then by taking the square root gives you your standard deviation. So the standard deviation for the number of hours teenagers spend on video games is 4.98 hours. And then if you look down on the data that we looked at in example 5 there on the grades, I put that data right here in X4, Y4. And so the standard deviation of the number of the grades for those students was 11.06. So I wanted to show you where to look that down. So the standard deviation was the hours was 4.98 hours, and then the standard deviation for the grades was 11.06. The last measure of variation that we're going to look at is the coefficient of variation. It is calculated by taking your standard deviation divided by the mean. So this is if you have sample data, the symbols, and if you have population data. It in essence is the proportion of the standard deviation is of the mean. And you would like that to be very small, because that would tell you that your data is not varying from the mean much. If this percentage is large, it means that standard deviation is very large compared to the mean, which is not a good thing. So let's look at a comparison. Example 6 says we have the average age of the accountants at Three Rivers Corporation is 26 years with a standard deviation of 6. The average salary of those accountants is $31,000 with a standard deviation of 4,000. Compare the variations of age and income using their respective coefficient of variation. And you can see the age. And C bar is 6 divided by 26 is 0.2307. So approximately 23.1%. And the salary coefficient of variation .129 is approximately 12.9%. So it looks like the salaries are not varying by as much as the age, which is a good thing. It means that they're not paying their accountants that are older any more or less than the younger accountants, because the salaries are not varying as much as the age. The last topic for lesson 3.2 is over what we call the empirical rule. So when our data is symmetric or bell-shaped, we're going to use this thing called the empirical rule down here. The empirical rule says that if we take the mean, so labeled right here, and if we add one standard deviation value to that and subtract one standard deviation, we should have approximately 68% of the data that falls between there. If we were to add another standard deviation, so two standard deviations to the right and two standard deviations to the left, we are going to add 13.5% on either side, and that's approximately 95% falls within two standard deviations. And then if we go out one more standard deviation, there's about 99% of the data. And so these percentages will always be the same. You're expected to write those on the top. That's how the common method of writing them are, and then the data values go on the bottom. We're going to practice drawing one in a moment. You will be expected to draw one of these on your chapter 3 project. And then we've also kind of been talking about back in chapter 2 when we looked at graphing, what considers an outlier, what is a data value that's strange or unusual. So anything that is outside of two standard deviations is what we would call unusual or a possible outlier. To look at it out here. So let's draw one together on the next page. So in a survey conducted by the National Center for Health Statistics, the sample mean height of women in the US between ages of 20 and 29 was 64 inches with a sample standard deviation of 2.75 inches. Assume that the heights are normally distributed. So if they're normally distributed, then we can use the empirical rule to fill in down to here. And I want you to fill in the parameters, which would be the data values down below, as well as the percentages labeled. So we said within one standard deviation is going to be 34%, and then another 13.5% out to the second standard deviation. Then 2.35 here, and then 0.15 past 3. So anything outside of two standard deviations below or above would be considered unusual. I always draw that on my graph, my picture, because I'm going to usually reference it somehow or look to see if I have unusual data points. So let's go ahead and figure out what data values would describe this. So our mean is at 64, and when we add a standard deviation, 64 plus 2.75, we get 66.75. And then if we add a second standard deviation, we get 69.5. And the third standard deviation is 72.25. By all means, pause the video and check these data points so that you know how to draw them yourself. Then on the left, if we take our mean 64 and subtract 2.75, we get 61.25 there. If we subtract another 2.75, we get 58.5. And then subtracting another standard deviation, we get 55.75. Once we have that all filled out, then we can answer some questions about our data set here. So it says, estimate the percent of women that are between 64 and 69.5 inches. So 64 is right here, and 69.5 means we're adding 34 plus 13.5, which is 47.5%. Estimate the percent of women that are taller than 69.5 inches. So that's beyond the 69.5. So that's 2.35 plus the 0.15. Don't forget that. So that's 2.5%. Then it says estimate the values that would be two standard deviations above and below the mean. So we marked those in our drawings. So two standard deviations above, we said would be 69.5 inches, and two standard deviations below, we said would be 58.5 inches. Anything out there? So estimate the percent of women that are between 61.25 and 72.25. So sometimes it helps to like lay a pencil or a marker down so that you can see. So that would be 34 plus 34 plus 13.5 plus 2.35. And that gives us 83.85%. And last but not least, it says, what heights for women would be considered unusual? Explain. So we said anything outside of two standard deviations. So that means anything less than 58.58 inches or greater than 69.5 inches would be considered unusual. Reach out if you have any questions. You will need to draw one of these for your chapter 3 project. You'll either need to print out the project and draw on it, or be able to draw it on computer. And the last page of our notes, on page 59, helps us summarize everything. We looked at this table when it was smaller, just the measures of center. But now it's also including dispersion or spread, we call that, our standard deviation. So if our data is symmetric, when our mean and our median are approximately equal, remember sometimes approximate, then our mean is the best measure of center and the standard deviation is the best measure of spread. However, when we have data that's skewed, whether it's skewed left when the mean is less than the median or skewed right when the mean is greater than the median, we use the median as our best measure of center and the IQR is the best measure of our spread. And hopefully you're wondering what the IQR is. And I'm going to leave you hanging because we're going to learn about the IQR in the next lesson video. See you in a few.